You have completed examples 1, 2, and 3 in section 2.8 in the first video of 2.8. Now this is section 2.8, examples 5, 6, 7, and 8. In these examples, we are studying composition of functions. So examples 1, 2, and 3 covered the operations, addition, subtraction, multiplication, and division of functions. Now we want to define composition of functions. Composition of functions. If f and g are functions, then the composite function, or the composition of g and f, is defined by g of f of x, which is g of whatever f of x is. To explain this a little bit better, if you have a real life example, it's telling you, let's say there are a pair of jeans and they cost $40. A composition function would be something where a retailer says today they're going to be 25% off, and if you buy before noon, it's an additional 10% off. So it's a composition function. The whole day off is 25%. So they would take off 25%, and then it has an additional 10% off if you buy before noon. It's composition in that you're going to have to determine the 25% off and get that new cost for those jeans, and then you take a 10% off the new amount that you came up with. So what happens in a composition, here's your $40, and first we're going to take off 25%. So 25% of $40 is $10. So 40 minus 10, your new cost is $30. So great, you're down to $30. But you came in before noon. So now what they're going to do is take the $30, oops, I'll put percent right here, and we're going to take 10% off of the $30, which is $3. So 30 less the $3 off gives you a new cost of $27. So you took 25% off the 40, gave you 30. Now you're going to take 10% off the 30 to get the 27. And that's what we're doing here. We're taking g of whatever f of x is, which means we have to find what f of x is, like finding the 25% off first. Then we take g of that, which in this case would be like the 10% off of the new amount. So find f of x, and then whatever that is, you're finding g of that. Let's do that with these examples. If I ask you to find f of g of 2, make sure you see that is not a times sign, that's a little circle, that means it's a composite function. So f of g of 2 means I need to find g of 2 first. So first, find g of 2. Because you're going to find, by definition, f of whatever g of 2 is. So I've got to find g of 2 first, so that then I can take f of that. So g of 2, put that in, would be 4 over 2 minus 1 inside my function here. And that would be 4 over 1, which is 4. So g of 2 is 4. So right here, g of 2 is 4. So I am finding f of 4. I want to find f of 4. So f of 4 is equal to, putting it in its function, 8 minus 1, which is 7. do another one. This time I want to take g of f of negative 3. That means you're going to find g of whatever f of negative 3 comes out to be. So we need to find f of negative 3 first. We need, like, taking the 25% off first. We got to find f of negative 3 first. So put negative 3 inside of the f function. So f of negative 3, oops, jumping ahead of myself, is negative 7. So now I know I'm really taking g of negative 7. Put that in. And I get 4 over negative 8. Put the 4, put the negative 7 in for x, minus 1. Equals negative 1/2. So g of f of negative 3 equals negative 1/2. In your ebook, it has an example. Let's try this one. You try it button if you want to use your ebook, and it may generate new numbers, so if you want to try it, you can, and it may give you new ones. I'm going to use this one. It says let f of x equal negative 5x minus 1, h of x equal negative x plus 2. Find f of h of 4. I want to point out f and h. We've been using f and g. I just want you to understand that f, g, and h are the common letters we use in writing out functions. So it didn't say g, but that's okay. It's just saying that it's another function. And I want to find f of h of 4. So I'm finding f of whatever h of 4 is. So I've got to find h of 4 first. So I'm going to put in the 4. Now notice that negative is sitting there, and the 4 goes in for the x plus 2. Negative 4 plus 2 is negative 2. So this right here, h of 4, is negative 2. So now I'm going to find f of negative 2. F of whatever h of 4 is, which is negative 2. So now I put negative 2 in. Negative 5 times negative 2 is 10 minus 1 is 9. Now you have examples in the practice problems that go along with that. And I believe it may be labeled wrong here. This, instead of 4, it should say 5 right here. Alright, let's look at example 6. In example 6, we have f of x is the square root of x. G of x is 4x plus 2. Given that, it says find each of the following. So we're just going to do this f of g of x. Now notice, in example 5, they gave us values. Let me go back. F of h of 4. F of g of 2. G of f of negative 3. But what if they don't give you a value? In this one, they have f of g of x and g of f of x. Well, it means you're finding f of g of x. So you're finding f, what is g of x? You're finding f of 4x plus 2. So you're just going to stick 4x plus 2 into f. So write down, and in place of the x, you're saying I'm going to let this go in place of any x in the other function. So that would be the square root of 4x plus 2. On this one, you're going to take g of whatever f of x is. So that means whatever f of x is going to go into g. So this time, this is going in place of the x and g. So g, f of x is the square root of x. So that's what you're substituting into g. So that would be 4 times the square root of x plus 2. So very easily said, this part, you can look at this outside part right here, that's going, whatever that function is, goes in f, and this one, f of x, is going to go inside of g. So f of g of x, 4x plus 2, goes inside f, and in this one, f of x goes inside g. Substitute them in. If it can be simplified, you can simplify it. I could these share a common factor of 2, but it won't really help me any. I could take the 2 out, and that would be 2 square roots of x plus 1, but it's not going to take me anywhere that's going to help me. So I can just leave it this way. I don't have to do the factor now. The example 7 is more practice of the same. It says determine the composite functions. Given f of x is 6 over x minus 3 and g of x is 1 over x, find each of the following. So in this one, we're finding f of whatever g of x is. And so g of x, we're finding f of 1 over x. So that would be equal to 1 over x. We've got 6 over 1 over x minus 3. And it's going to help to know how to make this easy with this complex fraction, because you've got a fraction inside of a fraction. Let's see if you remember what to do. What you want to do is make it a regular fraction. So if I multiply this by x, it will cancel that x and I won't have a complex fraction. But the thing about it, if you multiply by x here, everything has to be multiplied by x to keep it the same fraction. Make everything x times bigger to keep it an equivalent fraction. So we do that, and we have 6x over 1 minus 3x. On g of f of x, we're taking g of whatever f of x is. So we're taking g, f of x is 6 over x minus 3. So we're going to put that inside of g. In place of the x right here, I'm going to put 6 over x minus 3. And we get another complex fraction. We're going to do the same thing. Whatever's in the denominator of the complex part down here in this denominator here, we're going to multiply by x minus 3 here to get rid of the fraction, which means I have to also multiply the numerator up here by x minus 3. So I have 1 times x minus 3 over the 6. So x minus 3 over 6. You may have forgotten your complex fractions, so you've got a little refresher with that practice example. We have one more example to cover that covers composite functions. Let's look at example A. This example asks us to show that these two functions are not equivalent. In other words, they're saying show that taking g of f of x is not the same as taking f of g of x. We want to clearly understand those are two different requests. In this one, you're taking g of whatever f of x is. In other words, f of x is going inside of g. And this one, you're taking f of g of x. In other words, the g of x is going inside the f. And you're going to get two different outcomes. So this composition or composite function is different from this composite function. So they want us to show that if they give me these two functions to be defined as f of x is 4x minus 1 and g of x is 2x squared plus 5x. They want me to show that g of f of x is not the same as f of g of x. Alright, so let's just do this and show that the outcomes are different. So I'm going to first take g of f of x. So that means I'm taking g of whatever f of x is. So I'm taking g, f of x is 4x plus 1. So I'm going to substitute 4x plus 1 into g. Ooh, this looks fun. Okay, so everywhere you see an x in g, you have to put 4x plus 1. So 4x plus 1 is being squared here and then multiply by 2. So being squared and then multiply by 2. Here it goes in for this x and is multiplied by 5. There's your outcome. So I have to do a lot of cleanup work here. So this is 2 times 4x plus 1 times 4x plus 1. Remember, 4x plus 1 all squared means something times itself right there. Plus, and I'm going to go ahead and distribute this and get that done. 5 times 4x is 20x and 5 times 1 is 5. Now I like to do the FOIL part first and get that done, and then we'll come back and distribute the 2. So I'm going to FOIL that. I'm just going to leave this over here. First, 4x times 4x is 16x squared. 4x times 1 is your outer, that would be 4x. Your inner, 1 times 4x is 4x, and your last 1 times 1 is 1. Let's clean that up on the inside. That'd be 16x squared. Your 4x and your 4x added together is 8x. Just copying the rest down after I combine those like terms. So I've combined like terms inside. I'm going to distribute the 2. 2 times 16 is 32x squared. 2 times 8 is 16x. 2 times 1 is 2. And you still have plus the 20x plus the 5. And now it's time to look to clean this up. Let's see. I've got a 32x squared. And that stays in the front. Highest power first. Okay, I've got a 16x and a 20x, so that's going to give me 36x. And the 2 and the 5 give me 7. Alright, we did g of f of x. Remember where we're going though. I'm trying to show that these are not the same. G of f of x will not be the same as f of g of x. So let's go the other way now. Let's do f of g of x. That means I'm taking f of whatever g of x is, and that would be g of x is 2x squared plus 5x. So that's what I'm going to put inside of f. Alright, so that's going to be 4, and inside of that x right there, replace it with the 2x squared plus 5x, and then you still have the plus 1. So see, that's going in place of the x in this function. Alright, not a lot as much work on this one. 4 times 2 would be 8x squared. 4 times 5x would be 20x plus 1. And those are two different quadratics. So they are not the same. That completes the coverage of section 2.8. We've done it in 2 videos. Examples 1, 2, and 3 in the first, 5, 6, 7, 8 in the second. The first 3 were the operations, and these last 4 were the compositions. I hope this has been helpful. Be sure to do your homework in your MyLabs Plus. And if you need any help, make sure you talk to your instructors or your tutorials.